Hey everybody, Shea here with Method Vans. I want to take you through our water assembly cabinet. If you've been watching our videos, we went through our electrical assembly cabinet. And so opposing the electrical assembly is our water assembly cabinet. Our water assembly goes on the passenger side of the van. The electrical assembly goes on the driver side of the van, which to me makes the most sense because you would want your shore plug on the back side of your van that's not visible on your living side of the van. So for me, it makes a lot of sense for the electrical to be on the driver's side. So for us, the water cabinet goes on the passenger side, and you will see the same construction quality of materials being used in the actual construction of the cabinet. So again, we have our pure aluminum cabinet that's been powder coated with three coats of powder, been welded and fabricated meticulously, and has been specifically and designed for our water needs of our builds, which I think suits pretty much everybody out there. So let me take you through the componentry inside of the water cabinet. We don't actually plumb the water cabinet until it's placed into the van. We do that because everything then is in place and it's easier to finish up our lines coming through the cabinet. And then we're not moving it back and forth. So we do it once it's in the van. And so I can again do a quick video at the end showing you what the final product looks like. We have pictures on our website. If you look at any of our builds, it'll show our water cabinet in the end. And I'll highlight some of the cool features we use in the plumbing part of the cabinet. But my focus here is to show you the cabinet and the componentry that we're using inside of the cabinet. So this is our water storage and water distribution system. And so at the core of this is obviously our water tank. We had this water tank designed through our team. We designed it, and then we had a mold built, and we actually have these tanks built locally. So made in Alberta, Canada. With the tariffs that are happening right now, you don't want to be bringing anything in from the United States because the majority of it is getting assessed the 25% tariff. So we make our tanks in Alberta, and actually we're in Red Deer County, and the company that produces these is only about 25 minutes from us. So we get these made. They have our logo in them. They're made, the company that makes these makes RV tanks for all of Canada and throughout the world, all BPA-free, food-grade plastic. So, there's no concern with the quality of the materials that are going into our tanks. This is a 106-liter tank, so it's a nice, good-sized tank, bigger than probably most builders out there in terms of the size of the tank. And when I take you around the back, I'll show you one of the reasons that our tank is special is that we've really made the margin to the wheel well. There is a cutout of this in the wheel well because part of this cabinet, about this section, is through the wheel well of the van. And so again, our cabinets are designed for the Sprinter 170, the 3/4 ton, the 2500 exclusively. So it's not for a 144. It's not for a 3500 dually. So they're specific for the builds that we do, which is only the 170 2500. So we have a 106-liter water tank, as I mentioned. We have the nice cutout, and I'll show you that from the backside. And because we've tightened up that cutout, that's how we're maximizing 106 liters in this tank. And you can see, our margin. I mean, there's a bit of a margin here, but then the back here is where the bracket hangs down, and we need access to that bracket if this ever had to come out. So we're within, I don't know, at least a 1/4 inch of where we could be. So we've kind of went as kind of as tight as possible so that we can get everything in and out, and we're not battling that right off the bat. So we've got a 106-liter tank. You'll see our three, these caps that are in here for temporary. So we have 3 1.5-inch ports in the top of the tank. So these are just kind of sitting in there to protect nothing getting inside the tank. These 1.5-inch threads are for 3 things. One, we put in two senders. So these are water level senders. These are made by KUS in America, and they're high quality, they're resistance senders. So as this float goes up and down in the tank, that will give a different resistance reading that then is interpreted through either our analog gauge at the end of the cabinet or connected to our Servo GX in our electrical cabinet. So we run a wire from our Servo GX over to this cabinet, and then we can also have a digital label or display on our Touch 70 or on our phone of our water level in our tank. So I like the mechanical gauge for a quick visual out the back of the van, as well as when we're filling the van, we have a visual of where we're at. Then if we're in the van, we don't want to go outside to the back of the van, we can also check what our water level's at. And these are exceptionally accurate. The mechanical float is the best scenario. It's what's used in your van for your fuel gauge. So we have two of these 3.5-inch ports will be used for these. So one exclusively for the mechanical gauge, a second one of these for our electronic gauge through our Servo GX. And then the third port is for a draw vent. So as the tank is drawing down, the tank has to vent or we'll get an airlock. And so we use a ABS ventless, basically stackless vent that goes in here so that it can draw air into the system. But as you're filling, the vent closes, so it's not going to come outside of the vent. So it's only a one-way or a directional vent. So that's why we have these 3.5-inch inside of our tank. On the end panel, and I'll bring you around again for a close-up view at the end, we have 1.5 inches right here. This is for our fill. So our fill through a stainless steel filler is 1.5 inches. So we have a really fast fill. It's a gravity fill. So the level of the fill is up here. The level is here. So we're going to have a nice gravity flow down into our tank. At the back top, we have a 1/2-inch port that is then connected to our plumbing system for our fill vent. So remember, this was the draw vent, and then this will be the fill vent. And this goes up higher than our fill so that we don't get gurgling as it is being filled. So we want the air to come in, it goes up, down, and then actually expels out the hole in the bottom of the cabinet. So, and if we were to overfill the cabinet or the water tank, it would then expel water out that vent through the floor to the outside part of the van. And then our last end panel connection is a 1/2-inch port right here at the lowest port part of the tank, and that is our draw that goes into our pump. So that is our 106-liter water tank. It sits perfectly inside of our cabinet. Our cabinet has been specifically designed for and around this water tank. We have then a 90-degree angle that you'll see can bolt here and goes across, holding the tank down and in place so it could never bounce up. And then we have a bracket here so that it can't slide forward, and it's against the cabinet on that side, so it cannot go that way. So we end up with a scenario where the tank can't go anywhere. It's completely secure and safe inside of this cabinet. So drawing out of the bottom of the tank, then that will also be plumbed to a drain. So we'll tie into the drain. So that's how we can mechanically drain it. We just put in a mechanical valve for a drain. We don't like fiddling with electronic valves. They're failure points. They cause a lot of grief. So there's nothing like a traditional mechanical ball valve that we can use to drain the tank. We're only draining it at most once a year. So getting inside the cabinet once a year to do our winterization and drain our tank is not a big deal. So we have our drain would be tied in through there, as well as, like I said, through our draw. Our draw comes up through into our Pentair or a SureFlow water pump, which is a Revolution model, which is a bypass pump, which the bypass pumps through SureFlow are meant to minimize that quick pulsing that you'll sometimes hear in RV pumps. So that we want to have, nice long draws. So we don't have that pulsing. And so a bypass pump actually bypasses the water through the pump to minimize that pulsing that happens. So we come out through the bottom of the pump, out through the top. That top will then come out or through into our guzzle water filter. So this is a carbon block filter. So it's a good sediment filter, as well as it's taking out any sort of bad flavors or tastes in the water. So the carbon activated charcoal carbon inside there is doing that, as well as I think it's a 5 micron. So it's also drawing out any sort of large debris that's inside of the water. That then, so we come into there, and then this is their filtration as well as their UV system. So this is their complete package. So it comes through a UV lamp, which is inside of this top part of it, and then coming out the John Gusset fitting at the top, and then that would then feed into our distribution system. So our water is filtered for sediment, it's filtered for flavor, or getting rid of bad tastes. And then we have our bacteria and viral protection happening through the UV light. This pump or the guzzle only kicks in when it senses water flow. So it has a sense meter, and so we will through the LED indicators, it'll tell you when it's actually sanitizing, and that's only doing that while the water is moving through itself. So it's incredibly efficient. It doesn't have much of a draw, so there's no concern there. So through there, then obviously our distribution will happen. So our cold goes from there. It will then feed our hot water system. And so we have a cold in to our hot water heater. Now this is the Indel Webasto IsoTemp Slim Square. It's a 16 liter hot water tank, and it heats to a high level. I think it's 150 Fahrenheit. Is the temperature that I think it's just under 100 Celsius that it heats to. So it heats it incredibly hot, like nearly boiling. And that then goes through a mixing valve up here that our cold water also comes in and mixes through this bypass. So the out of the hot water then has been mixed with cold water so that we can get, obviously we don't want boiling water out of our faucets, but that gives us longevity of our tank without a very large tank. So because this is superheated water, we can mix it down through this mixer to get an adequate temperatured hot water out, and then this will last a lot longer. Now, we're in a van. We're not having extensively long showers. We don't have dishwashers, so things like that. So we're not using a whole lot of water, but we do love this water heater. One, as you can see, it's beautiful. It is marine grade, so it's really meant to be used in extensive environments. It's high quality piece of hot water heating, and it also has an additional feature that we don't use in all of our builds, and that is it has a coolant loop. So there's a in and an out. So you got two sources of heating in this hot water tank. You have a standard 115 volt plug, so that will go in here once this is wired, and clearly it's not wired yet because we're not inside the van, and that's coming from our electrical cabinet, which again isn't in the van, but it'll come out through the back of this directly into here. So you'll see no exposed wires. You'll see a plug here, and this would then plug in, which would then heat up the water via electricity, and that would be breaker through our electrical panel or AC distribution on the end of that panel. You can also heat the hot water via a coolant loop, whether that be through your vehicle coolant loop or a secondary coolant system. Heating it through the coolant of the vehicle is really kind of a silly idea for our application. There's probably other applications that it maybe makes sense on boats and things like that. But for us to use, coolant from the vehicle and having it completely pass the whole length of the vehicle to heat this is a very inefficient process. And in addition to that, it then makes the heating of the vehicle less efficient because we're drawing all that heat through wasting it underneath the van to try to reheat this water. Why would we ever do that? We wouldn't, because we are plugged into electricity, and while we're driving, we're producing between 200 and 250 amps of power through our secondary alternator. So our battery bank is juiced while we're driving. And if it's juiced, it can easily heat this while we're driving. So as we're driving, it's heating this. We get to our location, this thing is piping hot, and it will honestly last without any more heat for upwards of almost 2 days, day and a half for sure. And you'll still have some warmth of heat after 2 days. And maybe you want to heat it and get a little bit hotter water for a shower. So you can turn on the electricity and let it heat for 20 minutes before you have a shower. We like to have this running while we're driving. So we're using that electricity of the alternator as we're driving. This thing heats up to the 150, and then we get to our destination and we have nice hot water for some time. Now, if we were going to be out camping in a random location and not driving the van for an extended period of time, well, one, we would need to heat this with our electricity through our battery bank, which is then being replenished through our solar to some extent. If we need to start the van, we could do that and let it idle. It doesn't produce the best electricity when it's idling, but it does produce a decent amount. Or we have the option of putting in a secondary coolant system to heat the hot water. We've done that in our show van, in the Method Van's Ultimate Sprinter. We have a secondary heater, a coolant heater from S-Bar that is underneath the van, and then we have a coolant tank in here that is then heated through the secondary coolant heater that then has a pump that then heats through to this. So we could be randomly camping for a very long time, use a very small amount of diesel, and be heating our hot water, keeping it piping hot at all times. Now, there is a disadvantage of that. The one disadvantage is that the coolant cylinder or the coolant tank, which ends up being quite hot because we're heating this to a very high temperature, is inside of this cabinet, which then creates a lot of excess heat, which you'll see at the top when I take you around. This whole top of this cabinet is ventilated, which then that heat comes out, and then it ends up kind of heating your van. Spectacular if we're in the shoulder seasons or in the winter, less desirable when we're in 30 or 40 degree heat in the midst of summer. So it has its advantages, it has its disadvantages. And the strong disadvantage is the cost. We're adding a coolant heater, we're adding the coolant tank, we're adding a water pump, we're adding in a lot of extra plumbing, we're adding in extra power. We have to control our S-Bar air heater as well as our coolant heater. We don't like using a combo unit because combo units do one thing or the other well and the other not so well. So we use an air heater, which is great, the S-Bar air heater, which is great for heating the air, and then we like a secondary heater. And that's why this big space is here. So it has the capability of having a coolant heater. We don't upsell it to many of our clients unless we would know that would be a feature that they wanted. We have pre-drilled our coolant holes into the base of the cabinet in the event that the customer wanted to add that. It would be there to do that. So coming out of the hot, which is then mixed, then distributes to our hot water lines. Our cold water lines are distributed. Everything comes through our guzzle system. And our hot water lines and our cold water lines that feed the van come through the top of the cabinet. They cycle right down here through the, just on top of the wheel well, and then through our distribution to our water sink, which is on our passenger side in our galley. So that's kind of the gist of the water cabinet. I want to show you the end panel to show you what kind of features we have coming outside of the cabinet. Again, we have our rigid scene lighting, and this is opposing the one that's on the electrical. So this here is on the close side of the doors of the rear of the van, and the electricity one, or the electrical one, is on the far side towards the interior of the van. So this one is illuminating there, that one's illuminating there, and so our cargo tray that comes in and out of here is enveloped and completely illuminated very nicely. Again, we use a brush plate for our wiring coming through, because we have wiring for our water pump, we have wiring for our guzzle, we have wiring for our water senders and things like that. So we have some wiring coming through this. So again, we use the brush plate. Again, we use a small chunk of Panduit so that everything is kind of concealed and inside of there. And this has been designed so we have a lot of nice kind of space inside here to do all of our plumbing, which ends up somewhat hidden. And then again, we have our riv nuts in the bottom of this, which are for our tracking, for our sliding, our slider, for our full extension slider. And then we have our door, and our door in this case is not an acting door. And we've done that on purpose. One, because this is a big panel, and we need all the access to get our water tank in and out of there. If we ever had to take it out, we couldn't have a post in the middle and have doors. So we have this large door with these nice kind of grab handles. Again, this door only needs to go on and off once a year. And maybe not even once a year if you have heated storage. So it could even be less frequent. So we have this door, and it's pretty easy to install. As you'll see, we have a rubber track, or a rubber molding on the top of the cabinet. This just then sits on it and then perfectly goes up, and then corresponds to all of the riv nut locations. So we put in some nice 1/4-20 bolts in there. This is secured. It's there. It's got our logo and establishment on the cabinet, and kind of that's how we finish this guy off. So again, it's a very nice piece in the end, with matching finishes, obviously. So I want to take you and just show you kind of the ventilation at the top. Our new feature for this that hasn't been in all of our cabinets are some attachment points for our plumbing lines. We tried to use like adhesive tiles for the cable ties in there, and eventually with the heat of the cabinet, those just sort of fall apart and they don't stick anymore. So we've added some tabbing so we can properly adhere our lines. So that's kind of a newer feature. And then, so let me just take you around and show you sort of how things kind of finish off here on the end panel. And so, okay, this is our end panel. So again, this is our opposing one to our electrical, which I highlighted in our past videos. And so what do we have here? Well, we'll start with, we have a mechanical gauge. As I said, this is through KUS in the United States. So this gauge will correspond to one of our float senders. This is a backlit gauge, so that's kind of nice, and you can see it nice at night. You can choose the color. It's kind of cool. You can choose an orange or more of a yellow backlight on that guy. This is our filler. So this is the 1.5" fill. So this is just threaded. All kind of a beautiful chrome finish. So this is threaded. It's got a nice chain on it, so we're not losing it. We're going to stick our hose in here to fill our tank. So again, that will come out the right there, come out and go right into our fill, our 1.5" fill. So it's a very quick fill. And you'll see on the back side of this, there is an O-ring. So that seals and seats against this inner portion of this housing. And so if we do park on a big hill, or we're going uphill on an off-road and we have water sloshing back, it's not going to be coming out inside the van. This is a completely sealed system. So we use this one very purposely for all of those reasons. Next is our kind of our water out of the cabinet. In our builds, we don't do an interior shower. We do an exterior shower, and that exterior shower is accessed right here. So we use the Aquor system, which is a really nice system. They have these connectors. Some of these are built with an integrated check valve, so water can only flow in one direction. Other ones are completely through, meaning there's no check valve inside. So it depends what you're trying to accomplish. In our case, this does have a check valve, so this is an out only. You can't go in this case, and it's very simple to install. It's just in and a slight twist. Right? And you can do this under pressure. So you can see those O-rings. You can do this all under pressure of the system. You don't need to turn the system off when you're putting this in and out. And when you undo this, you maybe get like 3 or 4 drops out of here. It's pretty insignificant. And that's only because there's a small little bit that comes out that's kind of inside this pipe. But it's pretty tiny. That goes in and latches like that. And then we've got a normal water hose connection or garden hose connection. We've built this little cavity for our our builds. We put in a coiled water hose so you could wash down your bikes or wash down your dog or whatever you want with this longer hose. And then we also have a second one of these that we use for our outdoor shower. So our outdoor shower will also connect here. It goes up through and attaches to the door on the back door. And we have a curtain, a waterproof curtain that goes across the back doors. We have a system where we have a shower pole that keeps the curtain from banging into you if it's windy, which seems to be the case. And then all of our control is through this marine grade Ambassador water control. Aquor actually now has a volume and flow control, which we haven't put in a build yet. We just received one, so it will kind of go in our next build. But this is a marine grade, very little, kind of very cute valve for the system here. You can see it's very small and not very obtrusive. It's a simple up to turn on, and then you got your hot and your cold, and close it and you're off. So it's a very simple, gauge to kind of work, or a valve to work. So we've got our water gauge for filling, we have our fill, we have our volume and temperature control here, and then we have our out. And then we have a nice little storage area for whatever you want to put in there for the van. And then, of course, as I mentioned, on the back side, I wanted to give you a little bit of a view of the cutout. So again, I'll just kind of poke you in here, and you can see there is our gauge that will then tie into our sender and get power for the back light. We have the wiring coming out from our lighting in our cabinet, which will again get tied into our power coming through the brush plate. There, as I mentioned, is that rubber strip where the door will sit on. And then if we come around the back side, so you can see the wheel well cutout that we have here. And if we go and look at the underside here, you're going to see how tight we have. So this cutout is pretty close to the cutout of the wheel well. And you can see our tank precisely mimics that cutout for the wheel well. So that's how we can get a 106 liter tank inside this cabinet, because we've precisely built a mold that works really well to kind of just get outside of that wheel well. And then again in the back, we do cut off some of our final bolts, but it's pretty simple and straightforward there. And that's kind of a final view of our water cabinet. Next, I'll be taking you through kind of the final version of when this is all plumbed. And I just wanted to kind of highlight something that we do a bit different. So we use a color-coded PEX tubing. So we use red and blue, obviously red for hot, blue for cold. One thing that we do is we use all stainless steel crimps. So in the plumbing world, there are black crimps that are basically just a copper crimp that have been coated with black. There are pure copper crimps, which again will get a patina or green color over time. The black ones kind of start to look sad after a while. And then often in dentistry, veterinary medicine, medical grade hospitals, you will see stainless steel crimps. We use stainless steel crimps exclusively in every connection that is inside this cabinet. Again, setting us apart from other builders out there. When you open this cabinet, I want you to see beauty. I don't want you to see oxidized crimps or crimps that don't look very good. It's nitpicky, but that's how we roll. Nothing needs to be anything less than just absolutely spectacular and superior. So this is a walkthrough of our electrical cabinet or our water cabinet opposing our electrical cabinet that we've already highlighted. And as I said, next time I'll give you a bit of a view of what the interior looks like in terms of the final plumbing. And you can also hit up our website, go to methodvans.com, go to gallery. Our builds are there that we've showcased. And if you click on those pictures, you will see some water cabinet pictures that then show you what the final plumbing looks like. And if you go to the ultimate sprinter for the Method Vans build, you will see this coolant heater that we have inside of there and how that is plumbed as well into this cabinet. So again, thank you very much for joining us. And remember, get outside.